Okay, so let's start to solve this problem trapping rainwater. The question is given an array of with non-negative integers representing the height of blocks. If the width of each block is 1, compute how much water can be trapped between the blocks during the rainy season. Okay, so here is the simple question. The question is that we have given an array with some integers and we have to find it out the water trapped in between the buildings. Consider this as our example. We plot it on somewhere on graph. Okay, so the values are 3, the building is 3, the height of the building is 3, here 0, 1, 4 and 2, like this way. And we have to find it out the water which are stored or we will automatically get stored in between these buildings. So the first simple logic is that the minimum height of the building, right, from right side or left side, that amount of quantity will store, and how this is the height, this height will be stored, and the width, how much width is, right. So each unit has one width. Okay, so we will not consider each unit. Okay, we have to consider each unit, but we don't consider the width at each point, we just consider height at each point. Okay, so here it's so simple. The first time it's 3, the second time is 2. So here, on looking on this graph, what you will get that from left side the maximum value and right side its maximum value, and the next time minimum of both this value, that amount of height is required. Okay, and each point we are just subtracting this minimum height from its actual index, right. Okay, so for this I have created some visualization. I will show you. Okay, you will get clear idea about it. So I have taken this example. Okay, here at each point I am just storing the maximum element. Okay, from left side and from right side. And if we store the from left side and right side, after that we just had to find it out the amount of water at that building. Okay, at that index only. Why I'm doing this? Okay, so let's assume this as our example, and here in these two blocks how much the water will store, these two parts, and these are four parts, total 6 units. Okay, so how you will find it out? Just as you know, the right side and left side, consider you have taken the maximum values. Okay, and maximum these two values, from this you have taken this minimum value, right, and you just subtract it from this, the minimum 4 minus 2 2, right, and this 4 minus 0 4. So you calculate added 2 and 4. The value is 6. The 6 unit of amount it's stored from in between these four first four index, right? You just done that way. So I am just telling in that same way what I am doing. I am just storing the maximum value at each index from left to right, and the similar way from right to left. Okay, and while storing I'm just created this left and right vector, so you will get a clear idea. Here is a 4, again 4 4, the 6, then 6 6 and 6. Okay, so the next time this 5 is stored at the last. Okay, again 5 for this. Okay, so here is some I have used different kind of logic here. Okay, I will update that after time sometime. Here the 6 has to be updated. Okay, you can see 6 is updated, all the remaining elements are 6. Okay, here what we have to do is at the end we have to find it out how much water at each building we can store. So the first it's 0 because it's boundary of our graph, so it will not store any kind of. So we can find it out the minimum value from both of these values, and we will subtract the height of the current index. Okay, again the next time, the minimum of 2 left and right, the minimum is 4, and we will subtract this 2. Like this way, at each point we can do it. Here also the minimum value is 4, we subtract 0, then 4 is 2. Here the 6 is minimum, so we subtract the 6 from 6, it's 0. The next time 5 is minimum, you can see 5, so we can subtract 3, 2, then we will get 2, and the next time is 3 answer. So the last is 0. Obviously the minimum value is 5. Like this way, and after adding all this value, we will get 11 as our answer, final answer. So here what I have did, I have created two arrays, left side and right side. From left side we have to just take the maximum value at each index, and from right side we also have to take the maximum value at that index. After that we just have to subtract the current index value from its minimum of right and left. Okay, so I have written that complete code here, you can easily understand that. Okay, so this is our code. The code is so simple. I have declared an array length here, the left and right side. Okay, in the left side I am storing the maximum value at each index. Here 3, 3, 3, 3, 4, 4, 4. Okay, so in the left array it will store the maximum from 0 to, like, from left to right, and in the right vector it's stored from left in the reverse order. Okay, we have to store the maximum value, and in the last I'm just used answer. Okay, at each point we just have to find it out the minimum value of left and right array, right, which I have done here for this example. Here 5, the minimum value is 5 from 6 and 5, and we subtracted this 5 from 2, as already two blocks are present there. Okay, so like this way, and we have just written in the answer. Okay, this is the first scenario. Here the time complexity and space complexity is O of n, right? So because of that I have used another approach, and it's simple approach, so brute force. Okay, I will show you that as well. First I will show you why we are using that approach. Okay, here let's take the same example. Okay, so here instead of, I'm storing the maximum value from left and maximum value from right. Here what I have to do, let's take a scenario that we don't know, uh, we have no only one building, the maximum building. Okay, so consider this as our maximum building. We can traverse this the next point till we know that the last index is greater than its index. Okay, because why I'm doing this, this is the minimum index. Okay, so we have to find it out with respect to minimum index at each point. This we can calculate with 2. 4 minus 2, 2 amount of unit will store it here, because the minimum boundary of one of the side is 4, right? So whenever we receive the minimum value from either left side or right side, we can take that value and we can subtract that index, and we can store it in our answer. Okay, so here we just store this two value to the our answer. Okay, so the first time it's 0. Okay, the next time it's 4 minus 2, it's 2. Okay, again next time 4 minus 0, it will store 0. So here, okay, the next time we found the 6, right? This value, the left side value is greater than right side. So we can stop it here, and we just found from right side to left side, because we have to find it out how much amount of water will store. If we consider this as our like minimum, sorry, from we can traverse from this side, then here the amount of water will store 3 units, but in the right side there is a boundary which is less than this, right? So we can move to the this minimum index and we can traverse from right side. So 5, and this 2 we can subtract it, the 3 amount will store. Okay, here the 3 amount has to be stored. Okay, the next time here 2 amount is stored. Okay, this 6 will not store any, and this because it's boundary of, okay, because of that it's not showing anything. Our answer is 11. So what I have did here, I am just considering this. If the left boundary is less than its right boundary, then we can just increment this index. Okay, and each index we have to just subtract the maximum value to its current index. Okay, it's so simple, there is no nothing too different difficult thing. We have to just do simple thing. Okay, here I am declaring some variables. Okay, the first thing that I am traversing from 0 to nth index. Okay, here the first code is we can traverse from the value which is right side is less than its left side. Okay, so if this is scenario, then we can just move the simple way. If we found the maximum value from its left side, then we store it in the left and we can subtract the current value, and we just have to add it. We can increment that as well, and the remaining part, the re- vice versa in reverse order. Okay, so I'm just submitting it. Might be some of the tests. Okay, fine, it's working fine, I thought. Okay, here the time complexity is O of n and space complexity is constant, so O of 1. It's fine total. Okay then.